Alright, so welcome to this video here where we go through our calculations for Mavis. We're going to first calculate total annual snowfall by summing up the monthly snowfalls based on a season versus calendar year, right? So the last 6 months of one year and the first 6 months of the other. So it's a season versus a calendar year, right? And once we've summed that up, we can copy it down across all of our years from 69 through 2012 for a total of 43 years. Now we can calculate the descriptives for this annual snowfall. We'll do the min, the max, the average, and the standard deviation. Right, so this will give us a sense for how varied that snowfall is, right? So just simply the minimum of those totals, right? Click Control-Shift down arrow, close bracket. You can lock it, or you can just do what I'm going to do here and just keep typing equals max, and then select equals average, open bracket, down, Control-Shift down arrow, select, and then equals STD EV for standard deviation, open bracket, Control-Shift down arrow. Okay. And so this gives us a sense for how varied the snowfall is. Here we see that the standard deviation is on the same scale as the average. So we're not so much concerned with the overall range, but the fact that the variability is on the same scale as the mean, so which means we're going to get potentially some payouts here. We can see those potential payouts by just looking at a simple histogram. So let's do a histogram here with bins from 5 through to 75 in steps of 10, right? So 5, 15, 25, etc. So a little bit bigger than the minimum and a little bit bigger than the maximum. And so bins and frequency, we grab the whole block of cells beside that. Don't click anywhere. Start typing equals frequency, open bracket. Grab your vector of totals, Control-Shift down arrow, comma, and then grab the vector of the bins beside us, close bracket, and then hold the Control and Shift key and hit enter, right? So hold all three kick keys down together. Then we can insert a chart and just do a simple column chart. You will get a sense for that variation in snowfall for Seattle. Right, so let's get rid of the gaps between the bars. As usual, you could change the color while you're here if you wanted. Let's just call this Seattle, so we can remember which guy it is in case we move it around. And then the last thing we want to do is change the x-axis. We got to move the graph out of the way so we can see that data. Click Select Data, Edit for the x-axis series, and then just grab those bins. Alright, so here's a simple histogram, but gives us a sense for, there's a pretty wide range, and some of those low levels are highly frequent. And so we're potentially going to have some payouts because there's some rebates, because those occur at those low snowfalls. So we can start to map out those discounts by looking at our levels, right? So remember the critical percentages or discounts were 100, 75, 50, and then of course 0, right? So those are our 3 levels of discount and no discount. And those were a function of critical snowfall percentage of the average annual, right? So if it was less than 20% of the average annual snowfall, then we would get free tires. If it was between 20 and 30%, and 75% off. If it was between 30 and 40, then we would get 50% off. And if it was greater than 40, then no discount, because the argument would be is that we're using our tires. So let's put those critical levels in inches, right? So now we're simply just going to have 0.2 times average annual snowfall over here in the average for Seattle, right? So 0.2 times the average, and then 0.3 times the average, and 0.4 times the average, right? So we have our critical points in levels of snowfall, not just percentages. Now what we want to do is determine how often snow is hitting these critical points. Right, so it's sort of like a mini histogram, but instead of being descriptive in nature, we're trying to sort of isolate these payout points. Right, so we're going to calculate frequencies here for these different levels. Instead of using the frequency, we'll use the count-if function. So equals count-if. And we're simply going to count if snowfall, right, so grab our snowfall, and you can lock that with F4 if you want. Excuse me. And then comma, open quotes, less than or equal to, close quotes, and then put the ampersand, and then we can click on the cell that has our critical point in it, right? So we have to, the ampersand glues the logic to the number, right? And then so close quotes. And then we can copy that down for 20 and 30, and that will be the counts that are less than 20, less than 30, less than 40, right? We could also do the count of greater than 40, right? So we have the same critical point here. Oops, change that back to peak 4. Right, so 40% of the average. Now, just for completeness sake, that's count if our snowfall, right? So grab our totals, Control-Shift down arrow. Count if that snowfall, commas, open quotes, greater than, close quotes, ampersand, our 40% level, right? So this is the number of outcomes where we don't have a discount, right? So remember that these count ifs were less than 20, less than 30, less than 40, and greater than 40. But our discounts are less than 20, 20 to 30, 30 to 40, etc. So for our first level, it's just simply the number that are less than 20. But for our second level, we need to know how many were between 20 and 30, which is the number less than 30 minus the number less than 20. Right? Similarly for 30 to 40, less than 40 minus less than 30. Right? So that gives us the number in each of those. We have the remainder, i.e. those that are greater than 40, greater than 40%. The sum of those is our total observations, right? So here we have our 6, 6, and 3, and our 28, right? There's our frequencies. We have 43 possible outcomes, so we can now calculate our relative frequencies or our probabilities, right? So the probability of 100% rebate, 6 divided by 43. The probability of a 75% rebate, 6 divided by 43. Probability of a 50% rebate, 3 divided by 43. And the probability of no rebate, the 28 divided by the 43. And so now we have our 4 outcomes and their associated probabilities. And in essence, we calculate a weighted average, which is basically just our average rebate, or quite out what we refer in probabilistic terms is our expected rebate, right? So the probability times the outcome, right? So the probability of 100% times 100%, probability of 75 times 75, probability of 50 times 50, probability of 0 times 0. This gets us our average discount of just under 28%. So here we see that if we were to launch this promo in Seattle, we would be paying back on average just under 30%. Again, any given year, it's 150, 75, or 0. You could do the same thing for Ithaca, but in Seattle, we have these payouts that are going to be on average around 28. And so now we could decide if that's a good deal or not. As we talked about in lab, snowfall variable in Ithaca or less extreme, I guess is the better term. And so there'll be no discounts there. So still equally variable, but not as extreme, because our mean is different. Our standard deviation is on a different scale than our mean. That concludes our video.